Okay, so for those that were not in the last session, I'll just give you a quick debrief on the format. These are meant to be very conversational. We are going to try and tackle issues with as much bluntness and forthrightness as we can. We want these to be worth your time, and we're not going to focus on deep technology here. We're going to focus on sometimes the challenges that can arise around the technology, which are often bigger than the technology. In our last session, we made the statement that many of the problems we see, it's actually not a technology problem, it's a people problem, and it involves a lot of organizational challenges. We talked about that a lot in the last one. So I am super excited to talk with Sean today, Sean Knapp from Ooyala. Sean, tell us a little bit about yourself and your background before we get things kicked off, and I hope you find him as impressive a guy as I do.
Sure. Bottoms up. Undergrad and graduate computer science degrees from Stanford. Went straight from there to Google. Led out the Google's web search user experience team. We did about $1 billion revenue increase my last year there. Was one of the original folks that built up iGoogle. 6 years ago, left Google to start up our own company called Ooyala. We're about 300 folks strong today. We essentially provide white label technology to stand up whether it's Hulu and Netflix competitors or power ESPN streaming that I'm sure a number of folks here watch, all as essentially video as a service online. Quick background, I'm sure we'll touch on this a little bit more. Been using Cassandra since the 0.4 release. I think that's actually pre-DataStax era. So y'all have it really good. Those were really painful days, but happy to chat more about that.
Thanks, Sean. And yes, the ESPN streaming is what made me a fan of Ooyala. I love keeping up with my Louisville Cardinals from across the country, so that's a very good thing for me. And Sean has been doing some great things. What I like about Sean is Sean was doing big data before big data was cool, and he was doing some things at Google that were just super impressive. So let's talk about, before we get into the details of it, what is your level of familiarity and comfort with relational databases, whether Oracle, SQL, whatever? Where did you have them in your past? I know you used them at Ooyala, and we'll talk a little bit about that, but is that where you learned database technology, or did you learn it in conjunction with learning NoSQL? Tell us a little bit about how you got where you are.
Sure. I mean, honestly, I think like a lot of folks, right? I graduated in 2004. This was sort of, pre-academia teaching you about NoSQL, but every CS major back then at least takes at least one, if not many, database classes. Oftentimes you build a database. So that was just part of the foundational knowledge, right? I mean, this is the classic sort of LAMP stack era where everybody really learned those technologies. As I went to Google, obviously you get more familiarity. I wrote my first MapReduce in 2004, right? I was building technologies on top of Big Table way back before there was even anything out in the community, really. But didn't actually get familiar with the internals of how these things worked until a necessity, right? When we actually started to build up Ooyala, that necessitated, as our data requirements grew, that we be able to manage things beyond tens or hundreds of gigabytes, or even beyond tens or hundreds of terabytes of data.
So today, how many different types of databases do you run at Ooyala? And by types of databases, I mean we have relational databases, we have key value stores, we have column families, we have graph databases. How many types of different databases do you run?
In our production environment, and we actually try and keep the numbers fairly small. We can touch on that later because it's a whole other conversation as far as how many technologies you want your teams supporting. We run a large MySQL setup. I'll describe it. I can't use the word cluster. It's a master setup with probably 50 slave nodes spread out around the world for a lot of redundancy. We run 8 to 10 Cassandra clusters globally as well. Outside of that, we run a lot of Zookeeper. We run a lot of Redis. We do a little bit of Doozer, but we're moving away from that. My guess is those will probably be the 4, MySQL, Cassandra, Redis, and Zookeeper that we'll use for quite a while and probably won't be expanding or contracting that.
So the challenge for people today, again, if we're just going to get honest here, right?
Sure.
And, I love marketing, I love our marketing, and everybody else loves their marketing, but if you listen to the marketing from database vendors, and I'll put us in that category, you can get the impression, I call it the rainbows and unicorns world, where guess what? We just did it all. We solved everything. You don't need anything else ever. And those of us that have been around for a while and those of us that haven't, the younger crowd, we've just never seen that happen, right? The one kind of technology to rule them all has never manifested. And it's true, what do you think about the hardware? What do you think about operating systems? Certainly development languages, now databases. So my personal opinion is we're going to have to get comfortable in a world of, we used to talk about polyglot programmers. And that just means programmers who do a lot of different languages. I think we're into a world now where we're going to be talking about polyglot databases, where you're just going to have to get comfortable with it. But why is this the case? Clearly, if you wanted to, if you can wave a magic wand, you wouldn't, I presume, you wouldn't want 6 database technologies in your company. Why can't we get away from this diversity problem? And I'm talking, this is a 3-decade problem.
Right. There's no perfect tool because the cardinality or scope of problems is so broad. Whether it's really small data that's read and writes are transactional in nature, Zookeeper works really, really well for, right? Really large data problems, Zookeeper completely falls down on, right? And so the scope of problems we're trying to solve today are wildly different and orders of magnitude larger from a scope of problem perspective than they were 10 years ago. So as a result, you're constantly playing this game of how many technologies do you want and how many do you not. We tend to find ourselves somewhere in the middle, to be really honest. We, like I said, MySQL and Cassandra are very, very heavy users. We're fairly reluctant to try and introduce more technologies unless there's a large business case for it. Largely because you do start to get overhead, right? We run an infrastructure as a service and platform as a service teams. I'm happy to talk more about that. But as a result, you don't want 20 different services and technology stacks. One of the things we work with our teams on is, okay, look, there's probably one really cool, neat, shiny object. We always have the shiny object phenomenon.
Yeah.
Every engineer loves shiny objects. And so they're always finding that next new cool open source project to go build something on top of. But what we usually ask the question first is, can the existing tools work, even if they're not perfect, right? But you have to draw some sort of a threshold, right? If it's a problem that Cassandra works pretty darn well for, I don't need to go buy the next perfect tool because it's just more operational burden. But at the same time, there's a lot of stuff we do with MySQL that just is a better map for Cassandra. And so you do need to find what are going to be those key 2 to 4 sort of tools you're going to make available to your development teams and try and at least focus them on using those.
So we just did a press release that you guys were in today where Sean was kind enough to share a little bit about how they migrated from Oracle on some of their things and what that looked like. And we had Netflix in that case, in that release, and another company called OpenWave. And that's important for the ecosystem to help understand, what does this transition look like? How does it happen? What are the use cases? We do play in the space that Oracle's dominated for the last 25 years. And the reality is that real applications are moving off, and sometimes at an accelerated rate. Does that mean that relational databases are seeing the end of their life? Like, are they going away? Because that's what we hear all the time. Everybody wants that big, easy answer. So does this mean relational databases are going away? What future do you see for relational database technology?
Yeah, I think there's always going to be a future for relational database technology. I think the scope of problems that they're going to be used for will probably shrink over time, largely because we've been using relational databases to try and solve more big data problems for the last 10 plus years. I tell you, to give you guys sort of a sense of the order of magnitude we work on, and we're about to launch a brand new Cassandra cluster, and we're just not telling folks at the scale, but we're operating at a hundreds of terabytes scale on the Cassandra side. We collect about 2 billion events on a daily basis coming from all of our clients around the world. Reaches a
2
couple
billion with a B?
B, yeah, with a B. We reach hundreds of millions of users on a monthly basis, and we're constantly collecting data from those systems. So we're operating at a very large scale. But when we looked at our first generation of analytics, we essentially were doing just very basic, like bean counting equivalent of analytics, and that works okay in a MySQL cluster. But once you start to look at hundreds of terabytes of actual data, it just no longer scales, right? And we were trying to solve a big data problem with relational databases, and it just didn't operate as well. So I think what we're going to see over time, new sets of tools, right? You're going to see relational databases be used for what they were actually originally designed for. You're going to see the NoSQL solutions be used for what they're actually designed for. And I think we're going to get some more normalization there. Over time, I wouldn't be surprised if some of the NoSQL solutions actually start to eat up even more of the space from SQL, but this is a while, right? I mean, you have to wait through the education process of people going to conferences like this, it becoming more ingrained in academia, so that the new engineers entering the market get more educated. And that's a longer process, right? You need organizations to have readily available NoSQL services just as easily as you have SQL, right? And so all of this sort of supporting infrastructure just isn't there yet.
We hear that a lot. That is one of the inhibitors to the spread of a technology in a company, is that the team that actually does a lot of the provisioning and basically best practices, they're not caught up yet to some of the application teams, right? So I want to move into a concept here about this notion of you have an application, an existing application, it's a relational application, and here's a question I get asked all the time. How do you make the switch? Well, that's a pretty intricate question, so let's bring it up a level. When I wrote code in the 90s and when I wrote applications in the 90s, it was a very simple formula. You had an application, and that application spoke to a database, singular and singular. You had a one-to-one relationship. Now, what you're seeing is, well, the next step in the evolution was our application got split up. So the application actually became a conglomeration of what we called services. And years ago, this was called SOA. We talked about the services-oriented architecture. So we had a many-to-one relationship. But now, it seems like we've gone to this many-to-many relationship where when you say application today, and this is one of the hardest concepts for executives, and I found public finance market analysts, the guys who cover Oracle and those companies, they have a very hard time figuring this out because they want to know, where's that dollar going? Oracle, you used to spend that dollar on Oracle, where are you spending it now? And the answer is Oracle and Cassandra and Hadoop and this and that. So talk about this concept of an application really no longer being that nice, neat picture that we used to have.
Yeah, it's you can still have nice, neat pictures. There's just a lot more boxes and lines on them. I can certainly tell you what we do at Ooyala. It's a very service-oriented architecture group. We have, I'm guessing, somewhere between 20 and 30 different services that we run, and about 80 people in engineering, just for context, right?
What's that mean? When you say we have different services that run, help us understand, like, what does that really mean?
So if you think of it as literally different code bases, a service is something that can be fully deployed, independent of everything else. So in the classic days, right, when we started the company, you had, even on a single server, you had Apache. We didn't run PHP, but we had a Rails server, and we had a MySQL server. I didn't, mentioned it in the other panel we were on. People asked, well, why'd you use MySQL? And you're like, because I could type apt-get install MySQL, and it just worked, right? But that's just sort of what you did. Today, each one of these different services, it's caching layers, load balancing layers. We have probably, I'm guessing, 8 to 10 different just application servers alone. We have DRM servers. We have multiple data stores, and every single system is deployed wholly independently of the others. And from an engineering organizational perspective, this is great, right? You want, rather than one big behemoth push and deployment of your product, it's actually much safer to have 2 or 3 deployments a day that have very small deltas in change, and you're carefully monitoring the impact of those deltas, and it frees up your teams to run completely independent of one another. But this is a big paradigm shift that's happened in the last few years.
So did you do this on purpose, or did your developer teams kind of start coming at you with all these different ideas and projects? Who coordinated it all, and was it done intentionally?
Yes, so this was done fairly intentionally, and like all things, right? You allow it to run a little ways, and it gets a little disorganized, and you sort of pull it back in. When we first started, like all companies, right? You first build, and we even had this back at Google, right? You have this one big behemoth binary, like Back when I started at Google, it was web search, image search, groups, Frugal, alerts. Pretty much everything was one binary and was pushed once a week, and it was this really painful QA process. And eventually you sort of carve it out and you slice it up. Today, we still have like that big original binary that we pretty much don't touch because nobody needs it anymore. But every new product and service we have is built intentionally to be small and compartmentalized. And you get huge benefits from this, right? As you introduce new technologies. For example, we're moving largely away from Ruby, and we're primarily on a server-side technology. We're a Go shop going forward. The performance characteristics are just off the charts by comparison. But we can start to rewrite small services, bits and pieces here and there, and make really good incremental progress under that premise of, right, if you're going to touch the code, make it better, as opposed to trying to do these massive behemoth rewrites that just never actually happen, right? You get like a quarter of the way done, and your team gets derailed.
So were you taught this when you got your degree in school, or is this concept, or these concepts you learned from Google? Because the reality is, what he just described is actually prevalent today in organizations of all sizes. Even some of our smallest customers, that is what their application world now looks like. It is a conglomeration of services. But SOA sort of took off this idea of services-oriented architecture, then it died, now it seems like it's back. So what's happened, what's changed to make that a reality? Because this is going to be the hinge pin on how you can start to move and live in a world of relational and NoSQL, because what we're going to discover is the application can actually be talking to both at the same time, relational and non-relational. But how did all of a sudden we arrive here? Because a lot of us who haven't been tracking it day to day, it catches us off guard a little bit when we hear that this is the world now.
Yeah, I can at least tell you from my experience. They didn't teach it at Stanford. I hope they do now. They definitely didn't teach it when I was there, or maybe I didn't go to that class. They didn't really teach us this at Google per se, but I could identify at least, I think, two major trends that are large contributing factors. One, the world's getting more complex, not simpler. We have more products, more technologies, which, as a result, the cognitive capacity required to just keep the stack alone, just the technologies, never mind the code, just the technologies we use at Ooyala is impossible for any one developer to have, right? Never mind 10 developers. So you have to at least start to develop some level of specialization. So one of the things that we did, and this is out of sheer necessity in response to the fact that we had probably 8 different developers all messing around with Cassandra clusters, none of which had any operational experience at all, was we did what we called an organizational refactoring. Right? That works really well for engineers. We refactored. You don't call it a reorg, you refactor. And essentially, we pulled all of these services, all of the infrastructure, into platform as a service. So we took all the teams that had Cassandra clusters and we said, okay, you're no longer running your Cassandra clusters. Right? That's all being done by a single team. And we're going to actually focus specialty such that we have 4 or 5 folks that know Cassandra really well. Right? A number of them are actually speaking here. So that's one of the ones, right? It's just the sheer breadth of technologies you have to keep in memory, so to speak. The second is there's a lot more pressure to be able to iterate very quickly, right? Facebook has been really popular for this continuous build and deploy mantra, right? You write your code, you check it in, and it goes straight out to production. But everybody sort of forgets to be able to do that, it's not just how do I get code out to production now and fast, it's how do I do so safely, right? And to do so safely means you need to have very small deltas, you need to have a lot of mechanisms in place that track your systems and keep them healthy and ensure that you're doing small changes here, small changes there to separate individual systems so that they can be troubleshooted and rolled forward and rolled back very easily. I know when we're at Google and you have one big binary, you had hundreds of developers checking in thousands of changes on a weekly basis, right? You can't just simply roll that forward and roll it back very quickly. You need better compartmentalization of the changes that people are making.
So the rolling back part too, this gives the business a lot of agility for kind of an oops button. You try something, you guys are really innovative and you're always kicking out new things and new ways to do it. But you know what? I think it was Ballmer said one time from Microsoft, you can always wake up smarter, right? So we made a decision, it's not working out so well. If you try and do it on the old monolithic system that we used to write, forget it. Like, it's just impossible to go back that fast. So in this world, you don't have to unwind everything. You can just unwind that one little bit where you have the oops part. And so the cool thing about that technology is as well, you can now find the right database, whether it be Cassandra or a MySQL or whatever, for the right workload in your application. Is that how you
Right.
think about it?
Exactly, and that's what we see what we call our platform and infrastructure team. Their job is to provide those right systems, right? So MySQL as a service, Cassandra as a service, Zookeeper as a service, and just like what we had back at Google, right? Zookeeper was Stubby, Cassandra was Bigtable, et cetera. So we had all of these. And your job then as a developer was simply to pick that right tool for the job. And you find that everything's sort of settling in to the appropriate usage patterns as a result.
And is it fair to say where Cassandra is settling in, if we were going to give a more kind of business level description of that, is it fair to say that it's the online application at enterprise scale? Is that tend to be where you look to find something like a Cassandra?
It certainly is. We've talked about this briefly before, and I'd certainly encourage folks. He already gave his talk. One of our guys, a guy named Evan Chan, gave a talk, and I'd encourage everybody to also check out some of his slides. We're finding really interesting use cases even beyond that. Absolutely, I think this is where Cassandra wins in spades, especially with the stuff that you guys have been also adding on top. But we're finding really interesting other use cases that we can build on top, leveraging some interesting technologies like Spark and Shark that are allowing us to do, sub 100 millisecond, roll-ups across millions of rows for really interesting real-time analytics and feeding that data into things like our content recommendation engines at the same time.
So when did you found Ooyala?
2007.
2007. Okay, so you're probably actually coming up on this cycle that I'm going to talk about here in a minute. Many of us and many people in the room come from companies where they don't have the luxury of starting from scratch.
Yep.
So they've got a big, heavy relational infrastructure, but more importantly, they've also got an amazing resource pool who knows relational technologies. So if you now were to advise somebody who was going to start we'll call it post-relational, whatever, a NoSQL database, a Cassandra database project, what would be your recommendation on the percentage of resources that you need to go hire from the outside, who already know this stuff, versus what kind of effort would you put into trying to educate your existing resources to also be able to work on that project? What balance would you look to strike?
Well, I think you're looking at two different categories, right? You're looking at the maintainers of that infrastructure, and you're looking at the consumers of that infrastructure. On the maintainer side, right, like the classic DBAs, for example, I can tell you we have a 6-person team that runs our infrastructure. We have 8 people that came to the conference here. One of the big things, right, and this is why I do believe you need to invest internally in building up expertise in your company, is that there's that classic bus factor, right? You guys know the term bus factor? How many people are allowed to be hit by a bus until you're hosed? You can't have a bus factor of 1, right? You need to have redundancy in your own people. We didn't have that in the early days, and I was mentioning this earlier was, I would actually call Matt File from DataStax when we were making our migration from the 0.6 to the 0.8 clusters because things were burning down. We were about to have a fiery death. Based on the charts, we had a week to go until Ooyala's analytics product just went dark in a very, very public and bad way. And we had to actually have you guys fly people out and sit down in the trenches with our team for days to pull us out of that pain. These guys are great, don't get me wrong, like they'll do it and hopefully you guys charge them a lot to do that.
We don't like that model.
Yeah, it's really not a functional model and it really does not scale. You don't want to be in that position. You need that expertise in-house. And same reason why, even though we feel that we have a lot of expertise inside of Ooyala, same reason why we pay these guys for DSE is, we want the most stable, the bleeding edge. Well, I shouldn't say bleeding edge. The most recent yet stable features and capabilities that has support from honestly the best folks in the industry. Because, from our perspective, this is a mission critical component of our business at this point.
So how many folks are in your org, roughly?
R&D is about 100, in engineering, about 75 to 80. Okay,
so let's say you had 80 Oracle, SQL Server, and MySQL developers and DBAs. Okay, let's pretend.
Sure.
Okay, now you're getting ready to go start a new project, and you estimate you're going to need 30 people. How many of those 30 would you try and convert from your old base to educate and train versus how many would you go hire from the outside to work on that project? I'm trying to get a sense of how much effort and is it worth the effort, and what balance should that be between retraining your old team versus bringing in completely new talent who already knows it? Because the latter is awfully hard.
Yeah, and ultimately, honestly, you want both, right? We love the DBA mindset, applying it to Cassandra. There's certain principles. The DBA is usually the guy in the room that's screaming, data integrity and retention at all costs, right? Where oftentimes you get some newer age DevOps guys, and they're a little bit more cowboyish, and they're like, hey, it's okay. Even if we fat finger something, it'll be fine, right? Which is not the case. And so if you look at our team, it's about a 50-50 split. And I think that's really healthy, right? You want people who know your old systems, who are going to challenge you on some of the earlier principles that you've built your business on. But you absolutely want to bring in some of the new mindset at the same time. And that's roughly what our team is.
Now, practically, how do you then go about doing that? So this new project is coming, you've got this team of people, assuming they're willing, because sometimes they're not, and that's a whole different problem.
Yeah.
But let's say, yeah, I'm ready, I want to learn this new stuff. Do you pair them up? Do you hire the new talent in first? Do you send them off to training? Do you train them internally? How do you get them over the hump? Because it's been my experience that it takes about, depending on the sharpness of the developer, 3 to 6 months. Let's take a really sharp Oracle developer. I'd say 3 to 6 months is about an average time you can expect for them to ramp into really being productive on a NoSQL project.
Right.
So, okay, great. How do you do that? Do you like doing it internally and starting ahead, or do you just throw them in the fire? What's the right couple of best practices to do that?
We find, honestly, internal champions are by far the best for any new technology you want to introduce. We do a lot of pair programming. We do what's called mixer sprints. So
can you explain pair programming? A lot of people might not know what that means.
I mean, it's literally down to rubbing elbows with somebody, and you got a shared monitor, and you guys are actually walking through the code and building it line by line together. We do mixer sprints, so we'll actually pull people from 2 different teams and intentionally put them together as sort of a temporarily bonded team and make them drive new projects and initiatives together, so you get a lot of cross-pollination of ideas. But yeah, we find that I'm going to take somebody who's been doing something for the last 15, 20 years one way, and if you just throw them into the mix and say, hey, you should really go learn this new technology, promise us it's really important, you will never get anywhere near as much as you do getting 2 people who at least can have a respectful and productive dialogue together, which is sometimes hard with engineers, I get that. But put them in a room together to actually challenge each other and give them a strong business-driven use case for why they need to build out a product using new technology. That has always been the most successful strategy for us.
So, and a recommendation of mine, speaking not as a data stacks person, but as a guy who's been around relational databases for 20 years, I can tell you right now, hiring is one of the biggest problems you're going to have when you move to these new technologies, Cassandra or any of them, quite frankly. These engineers are in ultra high demand. So my recommendation as you start thinking about the coexistence of these databases is to do exactly what Sean said. Personally, I am a fan of the pair programming approach to this, because I think that's where engineers like to see things, and they like to see examples. They'd rather look at somebody's program than read a manual. And that teaches them a lot when they can sit down with somebody else. One of the first things you're going to have to get them over is this new world of what's called data modeling, which is just how you look at your data inside a database. If you take that back to your organizations and say, do we have people who know how to data model for NoSQL? If you do nothing else but just that, you will accelerate your ability to adopt in this world probably by an order of magnitude. The biggest failure we see from people who try and move from a relational world to the non-relational world are they try and what we call forklift their data model. So they try and take their exact same data model that they used on Oracle and drop it in Cassandra, and they die a miserable death. At least it's fast, though. It doesn't last long. So you can't do that. You really have to understand the fundamental shift in the data model. And once you do, by the way, everything else is not as scary as they think it is. So especially, like, I don't know how many made it to the keynote today, but when you see what we're doing with CQL, that is not scary to a relational person. They're going to look at that and go, oh, I get it. Create table, select from, insert into. That stuff's great, right? So that's really good to know that we can have that ability to do that, right? And I think it's important to understand that these are scarce resources.
Oh, very much so. I mean, that's always been the joke, right? Is one of the reasons why we first started working with DataStax was, well, we kept trying to hire everybody who was really good, and they kept taking your offers instead of ours. And so that was at least how we really first started a lot of the relationship, because when you're starting back in 2009, 2010, trying to gather that expertise, it's hard. And so, yeah,
Great.
You do have to be able to merge that strategy.
Well, Sean is amazingly gracious with his time. If you guys have further follow-up questions, he'll be around here for a bit. We're at a break right now, but I wanted to make sure you knew he was available. All his sessions from his team will be available. I encourage you to take your engineers and give them those links, because he and his company do some amazing things in terms of education to the rest of the market. So, Sean, thank you very much. We're at a break, so everybody enjoy the nice weather that we ordered, especially for this event. We paid extra for that. So go out and enjoy it, and take a break, get some fresh air, and we'll see you back here. Godfrey Sullivan from Splunk will be next. An amazing perspective on the market, and so I encourage you to come back in and listen to Godfrey chat a little bit about his views on big data. Thank you.